In this video, I'll show you how to use the direct truth table method to evaluate the validity of an argument. So we've got a new argument, a different form than the previous form. It doesn't really matter what P and Q stands for, since as we learned, validity is all about the form or the structure of the argument. But just to go through it, premise one is if P, then Q. So that's our conditional. Premise two is it's not the case P, indicated by the tilde, that little squiggly line. It's not the case P. And then our conclusion is down here next to the conclusion indicator. The conclusion is it's not the case Q, or tilde Q. So the first step, just like we learned in the last video, is take the stacked argument and place it horizontally on our truth table. So let's do that. So for step one, there's really not much to do. We just have to remember how to format it correctly. So we start with premise one on the left-hand side of the argument section. So we go if P, then Q. Right, we're just taking premise one and putting it down here. And then we separate the premises by a single slash mark. And then we put premise two down, which is tilde P. It's not the case P, whatever P stands for. And then we're ready for the conclusion. And the conclusion, as we learned, is separated by two slash marks. And then we just take the conclusion, which is tilde Q, or it is not the case Q, and we put it right next to those two slash marks. So there we go. The next step is to add all the possible combinations of truth values to the rows of the atomic statements. So what we have right now is we've got P and Q. So we're going to use those. We don't need an extra row for a negated atomic sentence. We can handle that over here in the truth table. So our two atomic sentences, whatever they stand for, are P and Q. We place them on the left-hand side over here, separated out from the argument itself, because this is just capturing all the possible combinations of truth values. In other words, this section over here is not part of the argument. So let's fill those in. I like to go where row one is where they're both true. The next row, P is true and Q is false. Then P is false, Q is true. And then we got to have the combination where they're both false. Okay, since we have the stacked argument placed horizontally, we can get rid of that. And then we move on to step three, add all possible combinations of truth values to the statements of the argument. So remember, this is premise one, tilde P is premise two, and then tilde Q is our conclusions. Just reminding ourselves of what the argument actually is and what the statements of the argument entail. So, like I said before, I like to work with each statement of the argument one by one. So I go premise one, row 1, 2, 3, 4. So let's fill that in, this is a conditional statement. We know the conditional statement is true, except in cases where the antecedent is true and the consequent false. So that would be only in row 2. So we already know that rule, so this is pretty much by memory. I don't need to look at each one because I know how I set it up. And I could always refer back to it if I get confused, right? If P then Q is true in all cases except row 2, where the antecedent is true, consequent false. So let's go to premise 2 here. So here we have a negated P. So we look at the truth value of P, and just to keep things very clear and very simple, I'm going to just add the truth value of P right underneath P, row 1, 2, 3, 4. So row 1 it's true, row 2 it's true, row 3 it's false, and row 4 it's false. But of course the statement is the negated P, right? The tilde, that's the main operator for this statement. So I need to put the opposite truth value for each row. So in row 1, if P is true, tilde P is false. Same thing for row 2, P is true, tilde P is false. Row 3, P is false, so tilde P is true. And same thing for row 4. Again, this is your main operator. So it needs to be clear when we are evaluating this argument, we need to make sure we're referring to the correct row here. So let's do the conclusion and then we'll talk about that a little bit more. I'll do the same thing for Q here. Let's take Q from these truth values over here into the atomic sentence. I'll put it right underneath Q and then I'll flip the truth value and put that flipped truth value under the tilde. So I'll just do this really quickly. So Q is true on row 1, false row 2, true row 3, false row 4. But the main operator is the tilde. So we flip it, false, true, false, true. So here's where things can be a little bit tricky in our next step. Okay, so step 4 is our last step. This is where we interpret the truth table to determine whether the argument is valid. And this is where things can get a little tricky when you have multiple truth values sort of in the cluster of the argument. So let's remember how the tilde is working here. And I'm going to mark this up a little bit. So let's look at premise 2 for a second. Premise 2 is tilde P or negated P. So when we look at the truth table and we're interpreting the truth value of premise 2, we're looking at the main operator underneath the tilde. I'm just going to circle this column. That's what we want to look at. And the same thing for the conclusion. The conclusion is tilde Q and the main operator is the tilde. So when we interpret this truth table, we're looking at the truth value under the main operator, and we're looking for any case where premise 1 is true, premise 2 is true, and the conclusion false, because that would equal, if you saw that on any row, that would mean this argument is invalid. I suspect this argument is invalid, but let's go through it. The truth table should visualize this pattern. Remember, the pattern of invalidity is when all the premises are true in a row and the conclusion false. So let's look at row 1. Here we have premise 1, true, premise 2, false, and the conclusion false. So there's no possible way for that row to indicate an invalid argument, right? It doesn't have all true premises and a false conclusion. It does have a false conclusion, but since premise 2 is false, it doesn't fit that pattern. Let's look at the truth value combinations for row 2. Well, neither of the premises are true. So on this row, it doesn't have all true premises and a false conclusion since these two premises are false. So far, so good, right? I mean, if we want to sort of check this off and be like, well, row 1 looks good, Row 2 looks good. That is, they don't show the pattern of having all true premises and a false conclusion. But let's look at row 3. Row 3 is where P is false and Q is true. Well, here premise 1 is true, premise 2 is true, and the conclusion false. So that is the exact pattern that shows that it is possible for this argument to have all true premises, and we just showed that with the truth table through this combination of truth values. When we plug it into the form of this argument, we get premise 1 is true, premise 2 is true, and the conclusion false. What that tells us is really everything we need to know, namely that this argument is invalid. We don't even need to go to the fourth row. We will, just to practice. But once we hit that, we have shown that it's possible for this argument form to have all true premises and a false conclusion. And it happens under row 3, where P is false and Q is true. So let's just finish this up. In row 4, we have a true premise, premise 1, premise 2 is true, and the conclusion is true. So that checks, but it really doesn't matter, since all we need is one possibility, one possible combination of truth values that shows it's possible for this argument form to have all true premises and a false conclusion. And that is how we determine that this argument is invalid. I would explain, I would fill out all my truth table, and I would be able to indicate that row 3 shows the argument has the possibility of having all true premises and a false conclusion. Therefore, this argument is invalid. The form is invalid.